Welcome to the Calculus AB video for skill number 113. I can simplify and solve exponential and logarithmic expressions and equations and translate between bases. And we've discussed that the Parthenon below is on the Acropolis. Technically there's multiple Acropolises throughout the area. The trivia question for the day is, what does Acropolis mean? Alright, for this skill we'll start on page 113A and focus on properties of logarithms. If you have two logs with a common base and they are added together, you can rewrite it as log of the two arguments multiplied. Similarly, if you have two logs with a common base that are being subtracted from one another, you could write it as the log of the two arguments divided by one another. One that we've seen pretty regularly already is when you take the log of some number raised to an exponent, we can move the exponent down in front so that we have y times log base a of x. And one that pops up occasionally is we can take a number and raise it to log base of that number, and it cancels out, leaving us with just the value of the argument for the logarithm. A lot of times we see this when we have ln of, we'll say 27x. If we just take e raised to that power, that cancels that because there's a common base and leaves us with just 27x. The change of base formula allows us to change from one base to another. So if I had an expression that was like log base 4 of 32, we could rewrite that as maybe log base 2 of 32 divided by log base 2 of 4. And if I wanted to simplify that further, I know that log base 2 of 32 is 5. And log base 2 of 4 is equal to 2. So this I've then been able to evaluate to be 5/2. Very commonly we'll just write them in the natural logarithm, so we'll put it in base e. Okay, so let's work through example 1, which says write as a single logarithm, and we have a expression here which consists of 3 logarithms. And we notice that they all have the same base of 3. So what I'm going to do is I'm going to take the first two and I can combine them using my addition property. So the log base 3 of x plus log base 3 of y becomes log base 3 of x times y. And then for the third logarithm, I'm going to take the 2 and express it as an exponent. And the reason I did that is so then I'm in the form of having two logarithms again, which I could combine into a single logarithm. So I take the first logarithm, and since they're being subtracted, I make the argument the numerator, and then I take the second logarithm and I make the argument the denominator. And then I go through and simplify my xy over x to the 14th, y to the negative 6th, and I have a final answer of log base 3 of y to the 7th over x to the 15th. In my opinion, this is a good example question because not only is it testing our logarithm properties, but it's also testing our ability to simplify exponential expressions. Okay, so in example 2, what we're doing is we're just solving for x, and this is more commonplace when we're dealing with simplifying and solving exponential and logarithmic expressions. In the first example I started pretty basic. I just have a number raised to x equals another number. So to get rid of that exponent, I take the log of both sides, and so I have natural log of 2.85 to the x equals natural log of 23. I use the exponent property of a logarithm that allows me to drop the exponent down in front. and then I divide both sides by ln of 2.85, giving me this for an exact answer, ln of 23 divided by ln of 2.85, and that is approximately equal to 2.994. I would like to point out that a really common mistake that students make is they will write this as ln of 23 over 2.85, and that is not correct, so do not do that. You have to take the ln of the top and the ln of the bottom. Alright, the next example we have e raised to the 5x minus 3 equals 7. So we can take the natural log of both sides, and that allows us to drop the exponent down in front. The 5x minus 3 goes in front, and that's being multiplied by ln of e, which is equal to 1. So that's why I did not bother writing it. And then we add 3 to both sides, and then we divide both sides by 5. So here we have an exact answer, and the approximate value is negative 0.211. This is the sort of problem that you could also use a calculator for, and you would graph the equation and see where the curve crosses 7. You can use the intersect function or various other features of the grapher. The next one says ln of x equals 5t plus 3. So here we're getting into multiple variables, and we want to solve for x. So the first step that I did is I wrote an exponential form. So the e cancels the ln, and I arrive very quickly at an answer of x is equal to e to the 5t plus 3. Which, if we wanted to, we could separate into e to the 5t times e to the 3. We don't need to do that, but there are problems in the future where that separation actually becomes helpful to us. So I'm pointing it out now. Really, when we get into differential equations, we'll see that sort of separation occur pretty regularly. In the final one, I've got two logarithms being added together. So log base 3 of x plus log base 3 of 10 equals 2t. So I use my properties to combine into a single logarithm. Log base 3 of 10x equals 2t. And then finally, I wrote it as a exponential. So I said 3 raised to the 2t is equal to 10x, and then I divided by 10, arriving at a final answer of x equals 3 to the 2t all over 10. And I'll leave it to you to figure out how I came up with this other representation of it. Thanks for watching skill video 113. I can simplify and solve exponential and logarithmic expressions and translate between bases. And the term city or Acropolis means city by the edge, and you'll find multiple places called the Acropolis. If you'd like more examples of a similar vein to this skill, please check out Calculus BC video number 206. Thanks for watching.